This is a Snowflake Masterclass. If you ever felt overwhelmed learning Snowflake or you're not sure where to start, this video is going to clear that up. I'm going to walk you guys through every single concept in Snowflake, starting from core basics all the way to advanced features, along with real-world techniques that every data engineer has to know. No fluff, no theory dumping, just practical demonstration along with explanation that actually makes sense. So if you like the video, don't forget to subscribe and share to your friends who actually want to know or want to learn Snowflake. That being said, let's get right in. In this masterclass, I'm going to walk you guys through every single topic that a data engineer needs to know about Snowflake, from beginner all the way to advanced. And for a few topics, I'm also going to demonstrate them live on screen so you will know how to work with these tools when you actually work on a project. To begin with, you have to know what is Snowflake, right? But before that, we have to know what is a data warehouse. Data warehouse is a storage that an organization maintains to store their historical data, because they need this historical data for analytical purposes, which enhances their decision making for future. So they need these warehouses to store the data, but they get tons of data every single day. And to store this data, this humongous data, they need a lot of infrastructure. They need a lot of hard disks to store this data, right? That is where cloud data warehouse comes into picture. A cloud data warehouse manages these infrastructure for you, so you don't need to manage that. You just need to pay them some money to manage that storage, and you just store the data in cloud. You don't need any physical space to store these hard disks. That is what cloud data warehouse is. Now we know what is a warehouse, what is a cloud data warehouse. But now, what is Snowflake? Snowflake is a modern cloud data warehouse. It is a cloud data warehouse, but it comes with a lot of modern features on top of that. It's not just a typical cloud data warehouse. It is an analytical platform. You can do data processing. You can create dashboards all in one place. And also, it has a lot of off-screen features like storing the data in a compressed way, which costs you less money because the data is compressed. And yes, it has a lot of features like that, and we are going to talk about those features in this video. Here's one of the core concepts of Snowflake. Snowflake is a cloud data warehouse. It helps us store and manage our data, right? But here's the thing. Snowflake itself is not a cloud provider. Cloud provider is the one who provides storage and the compute. Compute means the virtual machines which helps us run our queries. So Snowflake itself doesn't provide them. Snowflake leases these storage and compute from the cloud providers that we choose at the time when we create a Snowflake account. So when we create a Snowflake account, it asks us to choose a cloud provider. It can be Azure, GCP, AWS. And according to our choice, Snowflake leases the storage and the virtual machines from the cloud provider and provide those to us. This plays a major role in a lot of things like pricing or like connecting to an external source of data. Let me show an example of it. Here, Snowflake has 3 pricing models, and has standard, enterprise, business critical, and there is 4th one, virtual private Snowflake, where if you want any special requirement, we can just talk to the representative of their own to get a special plan, right? According to the cloud provider and the region that we chose when we create this Snowflake account, our pricing will change. By the way, we buy credits. We don't just buy plan, we buy credits using money. For example, here in standard, it costs us $2.60 per credit, and in enterprise, it costs us $3.90 per credit. But if we change this, you see that? If we switch the cloud provider, the platform, or the region, the prices vary accordingly. Let me show you. You see that? So it depends on which region and which cloud provider we chose. So it is so important to choose a cloud provider accordingly to our requirements. So if your organization is more relied on GCP, you choose GCP here and the region accordingly. According to those two, the platform and the region, the pricing varies. Now, let's see how to create a Snowflake account, free trial Snowflake account. Head to any of your browser, search for Snowflake free trial or Snowflake trial account, click on the first link. Like it says, Snowflake offers you 30-day free trial along with $400 worth of free credit that you can use in this 30-day free trial period. You don't need any of your card details, credit or debit, any of payment information. You don't need to put in any of that. You just need a new mail ID to log in and you'll get the free trial privileges. So start with putting in first name and last name and mail ID. And the reason for signing up, I'm going to say student, school, XYZ, choose a specific edition. Like I said, it asks you to choose a cloud provider at the time of account creation. And here it is. You have to pick one cloud provider according to your preference. And Snowflake will choose that cloud provider to lease any of the storage or virtual machines from that provider, and you will get charged according to that cloud provider. Then you check the box, hit get started. That's it. You'll get a mail to your inbox. You just need to click on it. You create a new credentials, username and password, and then just like that, you will be logged in on that PC where you do this, you create the credentials. But if you want to log into your account in a different device, from a different device, it's quite different. Let me show you how to do that. The same way, you say Snowflake free trial account, the same page. You head to the same page. Click on sign in this time. Here, it don't directly ask you about your username and password, not just the credentials. It asks you for account identifier, and you need your account identifier to move further. And here it says this part is your account identifier. Where you can find it is you just need to head to your Snowflake homepage. This is the homepage, right? Here, click on your username at the bottom left, and then click on session details. And right here, you can find your session. You can find your account identifier right here. You just need to copy this. Okay, it's pretty. You don't need all of that, like it says. You just need up to this one. Okay, up to this one. And then click on sign in. And here you need to put in your username and password. And that's it. You'll just log in a different device. You just need to know your account identifier. Now, let's talk about Snowflake architecture. Snowflake architecture is divided into 3 layers. I know these theory, but you have to know these core concepts, right? So bear with me. I will try to complete these core concepts faster, so you'll get into some interesting concepts. Okay, Snowflake architecture has 3 layers: storage, compute, and cloud services. Starting with storage layer, Snowflake storage layer is very unique that most of the data warehouses doesn't have. When you insert or ingest data into Snowflake, it don't just store the data raw, it just process the data to make the data retrieval or working with the data faster for us. And this data processing is managed by Snowflake itself. You don't have to do anything. I mean, there are a few other tools too to make the data faster. Like, let's say for Azure Blob Storage from Databricks, we can use Delta Lake for that to make the data working with data faster. But that is done manually, right? That is not automatic. But here in Snowflake, we don't need to do anything. We just ingest the data into Snowflake, and Snowflake handles the data processing. It actually processes the data and convert that big data into micro-partitions, separate micro-partitions. Let me use something here to sketch. Okay, let's say you insert a data that has 1,000 records, right? Now, Snowflake partitions them into a few micro-partitions, let's say 100 per partition, 10 of them, right? And each micro-partition is around 16 megabytes in size. Now, how this micro-partition actually makes the data, the retrieval of data faster means, let's say I'm going to query something. I'm going to query data. When I query a data, what does an actual typical data warehouse do? It goes from row 1 and checks every single row until we find the actual selected data to retrieve the actual selected data. But here in Snowflake, we don't go through all the records. It just sees the metadata of each partition. So it checks for first partition. It checks for the first partition, and this partition has maximum date. If it's sale date, if the records have sale date, it checks the maximum sale date and the minimum sale date. If the chosen data window in the query that we run is not included in this particular max and minimum window, it skips that partition totally. So it won't go through all those records in that partition. It skips that partition and moves to the second one, and then it checks the min and max of that partition. And so it checks the max date and minimum date. And if the data we are querying has the date, then it goes into that partition and gets the data out of it. So it skips a lot of partitions. It just takes 1 or 2 partitions to get the result out. That's how getting data out of this partition data is faster than going through all the records from top to bottom, one by one. It is faster, right? So yes, this huge amount of data will be partitioned into micro-partitions, and these micro-partitions have metadata like minimum sale date, maximum sale date. So it checks the metadata first, and if that metadata conforms that partition has the data that we need, then it checks into the micro partition, or else it just skips that partition and goes to the next one. That's how it works. I think you got the concept, right? And yes, that's how the storage works. And this method of searching is called pruning, by the way. Pruning is nothing but skipping the micro partition that we don't need and choosing the partitions that we only need is called pruning. So it uses pruning to fetch the data that we actually need to our query. Okay, we're done with the storage. Now, compute. Compute layer is totally separate from the storage layer in Snowflake. We can create multiple computes that works on the same single storage, and we can also scale them up and down whenever we want while we are working with the same storage. So it doesn't, they're independent. They work independently. The storage is separate and the compute is separate. You can, let's say you have multiple teams working on the same storage, same data. You can create one virtual machine for the data analysts, one virtual machine for data engineers, one for ML engineers, all separately, and all of them can work on the same storage at the same time. And the main secret sauce that Snowflake is popular about is if one compute, let's say ML engineers are using most of their compute engine, that doesn't affect the other compute, the other virtual machine, which is data engineers and data analysts. So if someone in one compute reaches the max limit of that compute, it won't affect the other computes. It just affects that particular cluster, that particular warehouse. So that's how they are separated. And then we have cloud services, which handles metadata, query optimization, security, of the data. So that's actually the brain of Snowflake. I think now you got the concept, right? The Snowflake and compute is separate. So you can create as many computes as you want to work on the same storage. And these particular computes are also separate from each other. If one compute has a lot of load in it, it doesn't affect the other compute. They're separate. So that's about the Snowflake architecture. Hope you get it. That's a core concept you have to know. Now let's have a look at the UI of Snowflake. First, so this is the create symbol. Here we can create SQL worksheets. If you want to work with SQL queries on the data, you can use SQL worksheet. There are Python worksheets you can create. If you're comfortable with Python rather than SQL, you can go with Python worksheet. There is notebook. Notebook is something similar to a Jupyter notebook. If you work with it, it is a lot convenient than just worksheet. If you have a lot of queries or codes to run, notebook is a lot easier. So we can create notebooks as well. And then we have Streamlit app, where we can create applications or dashboards using Streamlit. We have that option too, and we have Git repository to connect Git repository here. And then we have dashboard. We can create dashboard here, by the way. And if you don't know how to create dashboards in Snowflake, just in Snowflake, I already did a video. Go check it out. I think it goes like hotel dashboard. I created one project, so go check that video out. You'll know how to create a dashboard in Snowflake itself. There is tables, stage, view. Table is, we'll go through all these topics one by one, but for now, these are the options available. There are projects where we can, where we actually work, and there is ingestion. This section is to ingest data into Snowflake. We upload data into Snowflake. And this ingestion has a lot of options. Loading data into table. This loading data with a raw file. If you want to upload the raw file directly into a stage, we can load it from here with this option. We have Snowflake stage, AWS S3. We can use S3, which is the storage for AWS, and blob storage, which is storage for Azure, and the Google Cloud Storage for Google. We have all these options which we can use to import data into Snowflake from that source. We have transformations, which includes dbt. You can integrate dbt if you want with Snowflake. dbt stands for data build tool. If you don't know, dbt is a data transformation tool. You can use that. You can integrate that with Snowflake. I mean, that makes data transformation a lot easier if you want to use that. And there are tasks. We're going to talk about tasks later in deeper. There is AI ML. If you want to do any AI ML stuff with your data, you can use the go-to spot. Here you can find predefined models. You can use those models to train with your data and get the result out of it. You know what? Actually, let's use one of the models just to show you how it works. I'm going to use forecasting here. So this is the time series forecasting. Perfect. I'm going to create one. We have to choose any of the warehouse. Compute WH. Don't you worry. Everything I show you, this is just for the demonstration, nothing else. So we're going to create. We're going to select a database. I already have a database here created. So I'm going to select that. E-commerce demo. That is a schema. I'm going with sales clean. Okay, so this is the table that we have. So it literally asks you which is the target column. Like any other ML model or AI model, it has a target variable and independent and dependent variables. Dependent variables are the one who Now, let's talk about target and training variables. So these are the target variables. We want to find the possible sale amount for the future. We want to predict it using the past sale amount. So this sale amount will be the target value here. So I'm going to choose that. And the timestamp, because this is time series, we have to choose a timestamp column. So sale date is a timestamp. I'm going to skip this. Additional feature skip. Forecast horizon. So it predicts the next 2 weeks of sales if I say 14 days. So I'm going with 14. Like I said, guys, I don't want to overwhelm you with these topics. I just want to demonstrate how these AI and ML models work. They are already pre-created models. You can just train them and use them to predict the future possibility. I'm going to run these. So after filling all the details, it redirects to a worksheet where it already pre-coded everything. You just need to run them. So it says already exists. So I already use this one. So it says already exists. So I'm going to say V2 here then. Let's run that again. So that is successfully created. And then the second part is this one. Before that, I'm going to change the model name too, because I already ran it. It is going to say it is already existed. So I'm going to change that name. Run that. This might take a while because it is training the model before generating any result. So this might take a time. So I'm going to pause it. Okay, and finally we got the result here. This is the data that we already gave it. So we gave almost 30 records, which generated the other 14 records. So it predicted that. So it shows the forecast right here. This is a forecast, and this is the lower bound, and this is the upper bound. The possibilities, like the possibilities of minimum and max of that date. And that's it is that easy to actually use an ML model in Snowflake because it is already predefined. You just need to give it the data from your table, and it trains that model and generates the result for you. So I just want to demonstrate how easy it is to actually use an ML model here. Okay, that is done. Now, so we know what is AI and ML section is, and then we have monitoring, which includes all our queries that we run. It shows everything with the query ID here, where here the query ID is a lot. It is so important. We are going to use it in the further concepts where we actually time travel back to that query. So we use that query ID in this video for time travel. So yes, so everything we query will be recorded here. We can monitor here, right here. It says the status, if it is successful, if it is failed, and the warehouse and the user that ran. So you can monitor everything right here, and the time it took, all of it. So it took 15 seconds. I think that is to train the model and get the result from it. So it took 15 seconds. So it has everything and the time it executed too. So this is where you monitor your queries. And then we have marketplace, where we can get the products. When I say products, it can be an application, it can be data, it can also be, what else it can be? Apps. It can be apps, data, or products. It can be anything. Let's say, so you want the weather data here. So right here, you have the weather data for free. You can get some for free, or a few should be requested first. You have to request them, and then after approval, you will get it. So yes,
You can get these third-party data from here. This is the marketplace where you can buy the data, or you can get a few data or apps for free. And we have catalog, where we have everything listed right here, all the databases, all the tables, schemas, everything listed right here with the UI. And the important thing I forgot, there are a lot of interfaces for Snowflake. This web interface right here, we see the UI. This interface is called as Snow Site, and there is Snow CLI, Snow Park, a lot of stuff, but this is Snow Site. The web UI is Snow Site. We have data sharing. We can share data to another person or another entity from here. You can share it to public, to everyone in Snowflake, or you can just share it to the person you want to send the data to. I mean, a private data share. So this is used for sharing, and we have governance and security, where we can create users and roles. RBAC. We're going to talk about RBAC on our next. RBAC is our next topic. So I'm going to go deeper with that in the next one further. We have trust center, network policies, tags. So these basically governance and security. Who can access what? And then we have compute, where we create warehouses or manage them, maintain them. By default, we have all these warehouses. We basically use compute WH for now, but we can create a warehouse of our wish. Let's say one for data analysts. Like I said, we can create a lot of virtual machines or warehouses. I mean, one for analysts, one for engineers, one for ML engineers, all working on the same storage, like I said. So these where we create that. We have types of warehouses, and we have size. And the money or the price that we're going to pay to Snowflake, or the money that we're going to charge, is dependent on the size of the warehouse that we are going to use. If it is extra small, it's just 1 credit per hour. If it is 4x larger, it is 128 credits per hour. This decides how fast our machine will run. And there are advanced options to manage this, to make sure we don't get charged extra. There is auto resume, and there is auto suspend. Auto suspend is used to in scenarios where we leave the system open but unused. Let's say I just started working on this warehouse and I left, forgetting to close the warehouse, to suspend the warehouse. But if there is no activity in that warehouse, it suspends automatically after the desired time that we gave here, that we define here. For now, it is by default it is set to 5 minutes. So this warehouse will be suspended after 5 minutes of inactivity. So you don't get charged for the extra time that the compute doesn't have load on it. So that's what it is. And we have multiple clusters where we can choose the clusters from 1 to infinity. This is where this is the option where we want, let's say, sometimes I only want a medium level clustering size, but sometimes I want a large cluster. I want a large computational power. So I'm going to create a medium one, but sometimes the load might be a lot and I cannot predict that. Then I chose max clusters as 5 or 6. So when you only need medium, it only take one cluster, all right? But if the load is a lot higher, it adds the other clusters one after another, depending on the load. And that is also managed by Snowflake. You don't open the other extra clusters that are not actually working. It only creates the clusters if it is actually necessary. That's how it works. If the load gets higher, the clusters will also increase accordingly with this multiple cluster warehouse option. Yeah, we use that if we're not clear how much of computational power we actually need. That's when we use that. Then there is query acceleration. Yes, these are the factors that we have. And by the way, the pricing will be, we'll get charged for the warehouse. We'll get charged per second. I think it is. Okay, for storage, we'll get charged per terabyte per month. And for compute, we'll get charged per second. Okay, well, I know it says 1 hour, 1 credit for 1 hour, but it counts every second. All right, let's say now you just work for 30 seconds, and then later you work for the other later you work for another 30 seconds. It combines to all of that, so it calculates, it sums up every second. So that's what it means. So it calculates the computational power per second, not per hour. That is how computations work. That's how virtual warehouses work. Then we have admin, where we can control where we can see the consumption, credits used, and everything, all of that stuff, the admin stuff. Okay, we have that. Now, our next topic is RBAC, a very important topic when you work with an enterprise. RBAC stands for Role-Based Access Control. This is basically saying Snowflake who can access what. Let's say you run a company, you're the boss of the company, and you hire a lot of employees. You hire a lot of employees of different roles. You hire data analysts, data engineers, ML engineers, backend, frontend, and you don't want everyone to have same privileges, same access to the database. So you want to control that access, right? So you don't want data analysts to delete a table, to drop a table, to delete the data. You just want analysts to read the data, right? You don't want them to delete that. So you can control this access by role-based access control, RBAC in Snowflake. RBAC is a term that you will hear in a lot of platforms other than Snowflake, like Azure, GCP. Most of these use RBAC. RBAC is used to prevent, to prevent access to particular roles, where you don't give access to these particular privileges directly to the user. You give these privileges to an actual role, you name the role, you give privileges to the role, and then you assign this role to that particular user. That's how you give the access to that person. Let me show you. Okay, there is, let's say I am a data analyst. You hired me as a data analyst, and you want to give me access to the database, but only to read it, not to delete a table or create a table. You just want me to read it, not so you want to restrict any other permissions other than that. You just want to give me so I can only select from the table. I cannot create it or drop it or delete any data. So you want to give this access to me. So you don't directly give this access to me as a person, as a user right away. Instead, you give access to an actual to a role. Let's say the role name is Analyst. So you give access to the role first, to the role, and you assign this role to all the users, to all the employees who are actually data analysts. So this is a lot easier, right? instead of giving all these privileges one by one to every particular user, you can just predefine these roles first and then assign these roles to the user, all the users. That's how RBAC works. Now let's have a practical demonstration about this. Okay. Like I said, I already created a database. I just created this database to show these basic core concepts to you. Now, I opened an SQL worksheet. This is a worksheet. I'm going to connect it to a database. We have to connect the worksheet to a database and a schema. I'm going to create. Before going further, I forgot a point. There are three major roles. There are three major built-in roles that comes with Snowflake. The first one is account admin, who is basically a boss of everything. And there is sysadmin and there is security admin. Here, I am the boss of this account, this Snowflake account. So I got the account admin privilege here. There is system security admin who manages the roles and users. So he can create the users and the roles too. Whereas admin, he can do whatever he wants. He can create tables, he can assign new roles, create new users, but security admin can manage users and roles. There is sysadmin who can manage databases, schemas, and warehouses. But he cannot manage the users. He cannot create a user. He cannot assign the roles to the users. He can only manage the databases, schemas, and tables, and objects, basically, warehouses. Okay, that is it now for the demonstration part. Like I said, we're not going to assign the privileges directly to the user. We're going to create a role and then we assign the privileges to the role. So we're going to create a role first. I created a role named Analyst role. From that, role Analyst role successfully created. And I'm going to grant usage on warehouse compute WH. Compute WH is the default warehouse that we get when we create an account. So I'm going to grant usage on that warehouse to Analyst role for this role. That is successful, and so I granted usage on the database now, which is e-commerce demo. I already created that just for the demonstration. So I grant usage on that database to the role again. By the way, if you are confused, it doesn't matter. I mean, SQL is not case sensitive. That's why here I wrote Analyst role as lowercase. Here I wrote it as uppercase. It doesn't matter unless they are in double quotes. It doesn't matter. If you're struggling to understand any of these SQL queries, well, I will explain every single query that I write, but if you want to, have a good grip on these SQL queries, I already have done an SQL speed run where I gone through every single concept in SQL. So I'm going to leave the link of that video in the description. So go through that video. That gives you a very good idea of SQL and every concept in SQL. Yes. Then we have grant. And we have to grant usage on schema too. Did I run that? And this one. So I granted permission, usage permission on schema as well to that role, and then now I'm granting select permission on all the tables in the schema to that role. Select. Like I said, analyst should only read the data in the tables. So I only granted select permission to that user, to that role, not the user, to that role on that schema, on all the tables. Now I'm going to create a user and then assign this role to that user. For the user, I'm going to say, let's go with the Raj. Raj. Password should be in quotes, and this is case sensitive. So I'm going to say temp 823. Okay. Analyst role. Okay, now I'm creating a user with username Raj and password as temp@123. Default role is basically saying if there are multiple roles assigned to that user, this should be the priority one. That's what we are defining here. If the same user, Raj, has analyst role and the engineer role, the priority one will be the analyst role, because that's the default role here. We're not assigning the role here, but we're just defining the default role. The role is not assigned yet here. Must change password as false. Usually a user, when log in for the first time here, he needs to change the password. But if you say must change password as false, he don't need to, he can just log in. So I'm going to create that. So that user is created. And then grant role. What did I do? Now I'm assigning the role, analyst role, to Raj. Now he will get the privileges that are assigned to that role. Let me create that. Perfect. Now I'm going to show you how this works, okay? Let's open another incognito window. Snowflake, log in into that. I'm going to say sign in. Like I said, account identifier. Get the account identifier. Then sign in. Now we created a username. We created credentials, which is Raj, and then password as right 123. Oh, capital T. Okay, now sign in. Now I signed in as Raj here, right here. So the role is analyst role. So he only gets the privileges that are assigned to that analyst role, which means if we create a SQL worksheet, we can create an SQL worksheet. He can work on the database because we already gave the privileges, and he can work on the schema. All the tables in the raw schema, here are the tables, okay? Now, you can select anything from any of that table listed in that schema. Let's say sales clean table. I have to pick the database first and the schema and the warehouse, which is compute with WH. Run it. There you go. You can select the data, right? Because we already assigned that privilege to that role, but we cannot create a table here. Let's say, create the table or drop the table. Let's try to drop a table. Drop table sales clean. We run that. It says insufficient privileges to operate on table sales clean. So you cannot drop a table, you cannot create a table, but you can read from the table. That's the only privilege that is given to the analyst role. That role is assigned to Raj. That's how RBAC actually works. Now let's talk about databases, schemas, and tables. I know these are pretty basic concept, but I still want to make sure everyone watching should be able to understand every single thing. Okay, databases are the place where we store the data. That is the main container on the top. And then inside databases, we don't store the data tables directly in databases. There is something called schemas that hold databases. Schemas act like folders in your mobile phone, where just like the folders, because I use term folders because schemas used to organize these tables. They act like folders for the tables, where we can organize these tables in different partitions. And inside the schemas, there are tables or objects. There can be views, materialized views, formats, file formats. All these objects are inside the schema, and these objects hold the data. That's how the flow goes. Database, schemas, and inside the schemas there are objects or tables, and these objects hold the data. That's how it goes. Now, I also want to tell you about the types of tables. The major types of tables includes a regular table, a transient table, and there is a temporary table. A regular table is a table that stores the data permanently, and it also comes with two features. One is time travel, and the other one is fail. I think it's fail free. It is fail safe. A regular table comes with time travel and fail safe. I will let you know what these things are: fail safe and time travel. All right. So yes, regular table has these two, but the transient table has time travel, but not fail safe. And the temporary table has none of these. None of this. It doesn't have time travel, it doesn't have fail safe. Neither of them. Let's just write it here. Okay, now there is regular, and there is transient, and there is temporary table. Regular table, there is fail safe, there is time travel. Okay, first I have to explain what is fail safe. No, what is time travel. Time travel lets us time travel. So let's take a scenario here. If you drop the table, you can get it back. You can undrop it. If you drop the table, it is not gone permanently. You can undrop it and get the table back. That's how time travel works. And what is fail safe? Well, time travel does undrop the table, but it has a retention time. It only holds the table for a while after it dropped. A typical retention time for a table will be a day to 90 days. It depends on what we chose. So it has this time travel period where we can go back in time to get the table back. But once the retention period is over, it is totally gone from the account, from the Snowflake account. You cannot undrop it again. But there is failsafe. Snowflake offers you failsafe, where this file will be managed by Snowflake. You cannot find it anywhere. You cannot undrop it. You cannot find that file anywhere. But you can still get the table back by contacting the Snowflake support. That is what failsafe is. So Snowflake offers failsafe for your data. And here's the thing. Regular table has failsafe and time travel, which means if you drop the table, you can undrop it. And if the time travel window is over, you can still get it back by contacting the support. That is what regular table do. And there is transient table. Transient table does have time travel, but it doesn't have fail safe. So you can undrop it within the retention time. Once the retention period is over, you cannot, even the Snowflake support doesn't have access to that file. It is completely gone. It is permanently gone. Whereas in temporary tables, it is neither time travel, it has neither time travel nor failsafe. Both of them, none of them. And they all have their own applications. For the regular table, you use regular table to store the data that you want permanently to store them. There is transient table where you store the data which is less important, not as much as the regular data table. And there is temporary table where you only create this table just for that particular session. And once the session is over, you don't even need to delete it. It will be gone after the session is closed. So you create this temporary table for testing and stuff. So once the session is closed, this temporary table will be vanished. And even when you create this temporary table, this table will not be listed under the catalog. You cannot see it, but you can query it. Okay, that's how these table variants work. I think you got it. Okay, now let me demonstrate it. All right. Well, I cannot demonstrate the failsafe because I cannot contact the Snowflake support to get the table back, right? So what I do is I'm going to demonstrate the time travel, the drop and undrop it. I'm going to demonstrate that and the temporary table, how it disappears after we close the session. I'm going to do that too. Here, I'm going to create a table. Say, shouldn't be listed in any of the past tables. Okay. Customers. You know what? Because this is a demonstration, I want to show you guys everything from the beginning, creating a database, creating a schema, and then creating the table. Let me just take these things down. Don't need them. So let me drop database e-commerce demo. This will drop the whole database. Like I said, it still be retrievable because we can use time travel for that, but I did drop the database now. And yes, the catalog will not be able to show you that database because you dropped it. Now, I'm going to create the database, which is the main container on top. Create database e-commerce demo. This will create the database and make sure I'm inside the database. Yes, I'm inside the database now. Now I'm going to create a schema. I named it raw. Now when we refresh this, we got the database listed and we created the schema, and that is also listed here. Oh, but we got the old database that we already created here, and it has all the objects that I already have. But that's fine. This is how we create the database and schema. And then now let me create a regular table. Yep. So here I'm creating a table named customers with one single column, customer ID, and the data type as var char. Just for the demonstration. Yes. So now that table is created. I refresh this. There you go. Oh, now the other tables are gone. The other objects are gone. Just the table that I created now is here, customers. So that is a regular table. Now let me create like I said, I cannot demonstrate the difference between the regular and transient table because I cannot contact the support right now, right? So I'm going to demonstrate the regular table and temporary table. Temp table. I'm going to name it client ID. Client ID. That's it. So now I created two tables. One is the regular table and the other one is temporary table. Okay. Now, if I drop this table, if I drop the regular table, If I drop the regular table, now it is dropped, which means if we refresh that, we should not be able to see the customers table here. But because we have time travel here, we can undrop it. Table customer successfully restored. There you go. We can undrop it because that's a regular table. And the same happens with the transient table too. We can undrop the transient table too. But for the temporary table, once it is dropped, once it is dropped, you can still undrop it. Like I said, the temporary table goes off when the session is closed. Which means if I drop the temporary table, I can undrop that too, just like the normal table. You can do any action with that temporary table until the session is closed. And it just works like a normal table. You can do everything. It works just like a table until the session is open. But let's say if I sign out, okay, I signed out and sign back in, check my catalog tables, that is gone because I closed the session. As soon as I close the session, the table is gone. You cannot get that back. You cannot undrop it. You cannot, it doesn't have fail safe. It doesn't have time travel. It is gone totally. That is how temporary table works. That's just for testing. Now, let's talk about views. What is a view? A view is nothing but a query saved as an object. Okay. What I mean by that, let me show you. Okay. That's just a heading, by the way. Okay. Now, let's say I have a table called sales. There's sales. I have a table named sales. It has a lot of columns in it. And one of the columns says sales. One of the columns says sale. And the other one says date. Okay. The other one says date. And one of that says columns. All right. Now, this is a table. Okay. You want to query something from this table. You want to know, let's say you want to know the total sales, sum of the total sales. What do? You just write a query saying select sum of sale, select sum of sale from sales. You write this query, right? And you execute it. And this returns the sum of sales. This is a query, but a view is a query that is stored in an object form, just like a table. This is just a query, but you convert this into a view by just adding let me decrease the size by just adding create view and say total sales. Why do we do that? We don't want to save the query, or we don't want to write the query again and again. We just save the query as an object which is named as view. So whenever you want to see the total sales, you don't do this query again. You just select everything from that view. Where is that? So you just select everything from that view. You'll say, for the next time, you'll say select all from total sales. That's it. You don't write the whole query. I mean, here it's just a small, I just wrote a small query of sum of sales, but in real life, we do a big queries. And we don't want to write that queries again and again, or you don't want to save the raw query somewhere. So we create a view to save this query in an object form. So you don't get to write this query again. You can just write the select all from table sales. It works as a table and it prints just like a table, saying total sales. This horrible. It says total sales. It prints just like a table. It works like a table, but behind the scenes, it is not saved. The data is not saved in the view. Every time you every time you run this query, select all from table sales, total sales, which is our view. You don't get the data from the view itself. It runs the query behind the scene. It runs this query because this is the query that we created, that we use to create the view on top of it. So it runs this query and it goes back to the source table, it sales, and then pull the data out, and then it gives the data. It queries the data every time from the source table. And the advantage of creating a view is dynamic. Every time the data in source table changes, the data in view also changes. I will demonstrate it, but try to understand what I'm saying here. So let's say you have a table. You get the data from a source table. Okay. So whenever the data in source table changes, the data in this table will not change. But if you create a view from the source table, every time the data in the source table changes, the data in view will also change, automatically updated. That is what a view is. And the types of views, there are three types of views. There is a regular view, which is a regular view, and there is materialized view, and there is secret view. Materialized view is also a view and also a table, which means it stores the query. It stores the result of the query. At the same time, it also stores the data in itself in a separate memory. And it does that because to overcome the limitation with the view. There is a limitation with the view because every time when we query a view, it goes back to the source table. It takes a long time. It takes time to retrieve the data from a view compared to a table. A table is much faster. So to overcome that limitation, we get materialized view. We can create materialized view to overcome that the speed limitations. Materialized view act as a view and also a table at the same time. It stores the table. It stores the data of that query with it. So whenever you query the data, it don't go back to the sales table again because the materialized view itself stores the data in itself. So it is not that slow. Okay. And that's why I said materialized view is a table and the view at the same time. And there is secret view. Secret view is just a normal view, but the only thing here is the logic you use to create the view will not be visible to anyone else besides you. You can only see the logic. You can only see the select query that you used when you created the view, and nobody else can see that. That's how secret view works. That has their own applications. When you don't want to let others know the logic that you use to create the view, you can use secret view to create the view. So only the result will be available to everyone, but they cannot see the logic that you use to create that view. That's how views work. Now I'm going to demonstrate view and secret view and the table. I'm going to compare the view and the table. So you'll know how the view works automatically, whereas the table doesn't. Okay, let's head to that. Let me clean this part. I'm using a different database again, by the way, just to show you the difference between the views and tables. Now here I have hotel database, which I created in my past project, in my last project. I'm using that. First, select everything from the table, gold, bookings clean. Gold, booking clean. Okay, now we have this table already created in the database. Okay, this is a table, by the way. This is a table that is already created. Now let's create a view from this table, and create view. Well, I cannot demonstrate this difference between a view and a materialized view, so I'm going to differentiate between view and a table, because table doesn't update when the source table updates, whereas view will update when the source table updates. That's the difference, right? So I'm going to use that. Then I'm going to also use secret view to see how it works, to show you how it works. Now, first let me create the view, create view. In the name of the view, I'm going to name it total view, just for now, just for the example. Say as select. Like I said, a view is nothing but a query that is saved as an object. Now I'm going to select sum of total amount, and the max of num tests. I spelled it right? No. Tests. Yep. And say from gold booking clean. Now I'm creating a view. Let me create it first. Missing column specification. And like it says, I have to specify the column. I have to alias it when I do aggregation. So sum of total amount will be final amount. Okay, and for a number of cases, I'm going to say max guests. Max guests. This should run. Okay, now I created the view, which means I should be able to see that in the catalog. Under the views, total view. Then I'm going to create the catalog. There you go. Now head back to the worksheet and create a table from it. Okay. I'm going to use the same query, but this time I'm going to create the table. Total table. I'm going to name it as total table. And the logic, everything is same, but I'm going to create a table from it. Create table as from that. Run it. Okay. Now for the same logic, same query, I created a view and a table. Okay. Now if I select all from view, says final amount is 577,347 and the max guess is 5. And for the table, we'll get the same output for the table too for now. The same output, right? But what if we change, what if we update the data in the source table? What happens next if we query the same thing? The view will change, but the table will not get updated. That's what view is specialized for. So let's do that. Let me print the data from the source table first. Now I'm going to update a few records from this and see which one updates and which one don't. Here I'm going to change the total amount for a few records where the number of guests is 4. Let's do that. I'm updating the table and the table name is gold booking clean and set total amount equals 400 and where number of guests is equals 4. Now before updating, I'm going to print these results again. Well, they both have same results, right? So remember this number 577, 347. These are the number before updating. Now 577, 347. Now when we update this, the source table, 345 rows got updated. Now when we print the table first, okay, it still says 577, 347 as total final amount, whereas the view is changed to 600, 742. That's how views and tables work. Now let's do the same logic. Now we know the difference between view and a table. Now let's do the same logic, but let's create a secret view here. No, I mean, it's not secret view, by the way, secure view. Secure view. Let me create that. Oh, total view already exists. Okay. I'm going to say total secure view. I'm going to name it like that. And now it is created. Like I said, I created that, so I can be able to see the logic. So if we head to the catalog and go to the secure view, I can see the logic here. I can see the logic. I can see the definition. But what if the other person? Oh no. Oh, these are different Snowflake accounts. So I cannot. I did not create another account in this account. So I'm going to create another secure view in that Snowflake, and then I'm going to show you. Sorry about that. I just forgot. These are no, these not ours. No. Because I haven't created another user on that account, but in this account I have another user too. I'm going to do that here. Or else, wait a minute. Let me just run these and create the user in that account too, so I can just demonstrate it right there itself. No, that's not a good idea. Okay, that's not a good idea. I'm going to create secure view here itself. Now, what are the tables I have here? I have customers. Okay. Create secure view. Name it. Total secure view. Yes. Select. Oh, there is only one column, that is customer ID. What can I do with that? I'm gonna say count of customer ID from customers. Okay, now let's create that. Missing column specification. Say as customer count. Okay, now we created a secure view, which means we should be able to see the view here, and we should also be able to see that the logic, the definition of that view, because we created that. I can see the logic here. I can see the definition because I created this secure view, right? But what if another user with the view privilege, actually with the read privilege, try to access that secure view? Will he able to see the definition? Let's find out. I already created another user, which is Raj, which has view permission, which has read permission. So I'm going to grant access to that secure view. Total secure view. Analyst role. So I granted permission to that secure view, to that analyst role. Now I'm going to log in as a Raj, and go to catalog, portal DB, schema, and views. I should be able to see the schema. I should be able to see the secure view here. But he cannot see the logic of that secure view. But he can see the logic of any other secure view, any other view, but not the secure view. So these also a view that we created, but these not secure view. So he can see the logic here. Whereas for secure view, he cannot. That's how secure views work. Okay, we're done with that topic too. Now let's talk about file format. If we want to import any data into Snowflake, well, we have to import any data into Snowflake, right? So that data will be in a file format, right? And we import that data into it. But before importing any file with the data into Snowflake, we have to define the file format. That is like saying Snowflake what type of file we're actually importing into it. So Snowflake can understand and do operations according to the file format. So we're just saying Snowflake, okay, Snowflake, I'm uploading this type of file. So do these options or these operations with it. That's why we use it. And Snowflake compatible file formats include, that's to watch, CSV, JSON, RK, Avro, ORC, XML. So these are the file formats that are compatible with Snowflake imports. So creating a file format is a prerequisite before we import a file. There is a few more prerequisites before we import the file, like like creating a stage. But yeah, we will talk about it later. But for now, this is how this is what we have to define. This is this part of the prerequisite to import a file. We have to define the file format. And let me show you how we can define the file format. Let me create another SQL worksheet. I'm gonna name it sales CSV format. We have to define the file type. Like I said, we're saying Snowflake what file type we are going to import. The type is CSV. And now, while importing the file format, we can, this is not mandatory, but we can use options while defining it. So these options will be implemented to that file format. Let me show you a few examples. There are a lot of file format options, and they depend on what file type you're choosing. I'm going to show you a few. Let's say 4 of the main options that we have. Firstly, field optionally enclosed by okay. So this option, we define this option if any of the fields in our in our file that we are going to import has these double quotes in it, which will be imported as is, and we don't want those quotes to be imported a part of the data. So we can take those double quotes out using this. If there is double quotes, we can take them out. That's why we say field optionally enclosed by, and we use double quote. We define double quote here. So if any of the fields is enclosed by double quotes, the double quotes will be ignored. And there is field delimiter equals comma. When we define the type as CSV, we don't need to define the field delimiter because the file itself is CSV comma separated values. So even though if we don't define this option, it still takes it as a comma, the field delimiter as comma. But in case, let me show you. Now for my example, I took this, I'm going to take this CSV file that I created here. See, this is a CSV file, so all the fields are comma separated. But what if they are separated by backslash, or they're separated by this? They're separated by any other symbol, let's say semicolon. We can define, if it is separated by semicolon, we can define field delimiter as semicolon. So it takes that as a delimiter and divides those fields accordingly. But we don't have to do that. because our data is actually clean, so we don't need to use it, but just saying that's another option that frequently used. And then we have skip header equals 1. Most of the CSV files, I mean any CSV files, mostly have the first line as header, right? Date and sales, and we don't want that to be part of our data, which means that is nothing but error. So we want to take that out. We don't want the header to be part of our data, and that's why we use skip header. So it skips the header, and one represents the one line. Last one is null if say null okay. What is null if? Null if option, we use null if option to deal with these, deal with the fields that has nulls. I mean, not literal nulls, but the string nulls. Let's take an example of our data. Okay, so we have this data, and if there is any field that says null, it is taken as string and not null value. So to deal with this, we are using null if here. So if any of this matches with any of the field that is in this file, so it takes it as null data type. Right now it says null, but it is string data type. But it actually replaces that with actual null data type. That's how we use null if. And that's 4 options that I told you about. Those are the most used ones. And yes, there are a lot more according to which file type we choose. They differ, but this is fine. I'm going to run this. It already exists. All right. Wait for replace that. Now it is created. So I already created the file format, so it says the file format already exists. So I replaced it. Now it is fine. Just drop this. No, that's it. That's it with the file formats. Now let's head to our next topic, which is stages. Like I said, there are a few prerequisites that we have to create before we uploaded any data file into Snowflake, and creating a stage is one of the prerequisites. Let me go back to that and whiteboard. There are 2 types of stages: internal stage and external stage. Internal stage, external stage. Okay, this is here. There is internal stage and external stage. Internal stage, I mean, what is a stage? Stage is like a waiting room. When we upload a file into Snowflake, the file will stay in this stage before the data inside the file gets transferred into an actual table. So we use stage because we can't just directly upload the file into the table upload the data into the file into the table. So we have to upload the file into the stage first, and then we transfer the data that is in the file to a table. That's how it works. That's why we use stages. And there are two types of stages, which is one is internal and the other one is external. Internal stage is when we store the files inside the Snowflake. External stage makes us store the files outside the Snowflake in any of the cloud storage. Why did I? Okay. In an actual internal stage, let's say this is Snowflake. We create a stage here inside Snowflake, and here is the place where we upload the file into, which is good, but we are actually using the storage inside the Snowflake now. But what external stage do is, it is independent. The storage it uses is independent to Snowflake. You don't use a Snowflake storage, but it uses any other cloud platform storage. This is any of the cloud storage, and there it creates a stage. We define it as a stage. We don't create a stage. We define a cloud storage as a stage, cloud bucket as a stage. In that bucket, we store the file, and that bucket acts as external stage. It's just a normal bucket, but we just define the bucket as an external stage inside Snowflake. So it considers it as an external stage. What we are doing here is we're not using the storage that is inside Snowflake. We're using storage in the cloud platform, in the cloud storage. So yeah, there are two types of these are the two types of stages, and there is one more thing you have to know, which is directory table. Now, a directory table is a virtual table that stores the list of files that are in the external stage. When we create an internal stage, and if we upload multiple files into that internal stage, it is easier for us to have a look at the list of files that is stored in that internal stage. It is easy, but it is hard to look at the files that is stored in the external stage. That is where the directory table comes into picture. We use directory table to have a look at the list of files that is stored in the external stage. That is why we use directory table, to see the files that are stored in the external stage. That's it with the stages. Okay, let me erase this. Okay, that is done. Back to here. Now let me create a stage. By the way, what I'm doing now is I'm doing how we can upload, the basic way how we can upload a file. Okay, upload a file and transfer the data in the file into an actual table. The basic way first, and then we go with the other way. We'll talk about it later, by the way. Yeah, right now I'm just demonstrating how we can load the file into Snowflake and transfer the data inside the file to a table in a very basic way. This is the very basic way I'm representing. Okay. To create a stage, create stage. STG econ. The file format that we already defined is that. Okay, now let's run that. Now we created a stage here, which is an internal stage, by the way. When we refresh this, we should be able to see the stage here listed. We have the stage listed, and also the file format that we created is also listed here. Now we are done with the prerequisites. What we are missing is we need a table that stores the data inside the file that gets loaded into stage. So before doing that, we haven't even uploaded the file yet, right? So let's do that. To upload a file into a stage, we go to ingestion, add data, load file into a stage because we created a file, chose the database, chose the schema, and the stage that we created. For the file, browse. I'm going to use dailysales.csv file here. Click upload. Now the file is uploaded. I'm gonna click go to files. There you go. Now we uploaded the file into the stage successfully. The next step is to create a table and then transfer the data inside this .csv file into the table. Let's create the table first. Add here and create table, sales. Seems like I already have a table with that name, so I'm going to say create or replace. So if just in case if there is another table with that same name, it replaces the table with this one. And for the first column, I'm going to use rate of sales as string, total revenue as string 2. You might wonder, I'm using string for string as data type for every column because our initial table, this will be our raw table. This will be the table that stores the raw data. So this is how it goes. We don't want to lose data because of the data type mismatch. So we use string here. String accepts any type of data. So string accepts any string data, right? Yeah. So any data that is in the CSV file will be transferred to this table, and then we parse it with the actual data types into another table. That's how it works. Now I'm going to create this initial raw table. That is created. Our next step is to copy the data inside the file that is in the stage to this table. To do that, there are a few types we have to talk about, which are data loading methods. Okay, so there are 4 data loading methods. I think I have a slide for that. Let me show you that. Yeah, here it is. There are 4 data loading methods. One is copy into command, and the second one is Snowpipe, and the third one is Snowpipe stream, and the fourth one is external table. They all have their own applications and their own advantages too. The first one, which is copy into command, is a basic way we copy the file from stage into the table. That is the basic way we follow. We just import the file into stage, and then we just run copy into command, where we copy the data from the file to the table. we paste it in the table. This is the very basic way, but the problem with this is it is good. The problem with this is we have to run copy into command manually. It is good for the basic data transformation where you have files and you want to upload massive files at the same time, all at once. You can just write copy into to just transfer this massive file from the stage to table, and it should be done manually. But there is another way where you can schedule copy into using task. We're going to talk about task later, but we can do that. We can schedule copy into with task, but it's still, we can only schedule it. We can only schedule to run copy into at certain intervals of time, for every 5 minutes, for every 1 hour, like that. We can run the copy into by scheduling it, but we cannot use it as a stream or near real-time stream. That is why there is another way, which is Snowpipe. This one. Snowpipe offers near real-time streaming. It is not real-time streaming, but near real-time streaming, where we define an external stage. We talked about stages. We talked about external stage, right? An external stage is a stage that is that stores data outside Snowflake, not inside. Outside Snowflake in a cloud storage. So we define a cloud storage as an external stage. We define an external cloud bucket storage as an external stage, and we upload the file into the external stage, and we define a Snowpipe. And this Snowpipe copies the files, copies the data from the files that are stored in the external stage to the table. But what's special about Snowpipe is we don't run it manually, we don't schedule it, but what it does is we define the external stage and the table for that Snowpipe. What Snowpipe does is whenever a new file loaded into external stage or uploaded into external stage, that will the Snowpipe will automatically get triggered and copies that particular new file, the data inside the new file, by the way, the data inside that particular new file into the table. That's how Snowpipe works. It doesn't run continuously, but whenever a new file gets uploaded into the external stage, it gets triggered and then it copies that data in the file to the table. It is very efficient for large data, but not real time. It is not real time, it is near real time. But next one, what we are going to talk about is Snowpipe Stream. Well, I haven't included that in this slide, by the way. I think I forgot, but there is another thing called Snowpipe Streaming. This offers real-time streaming. Where Snowpipe offers near real-time, this is real-time streaming. But this doesn't have any stage. The data comes from any sort of API, will directly gets into the table in real time. This is best when you get the data continuously, the new data continuously getting flooded into the system. Snowpipe streaming is best fit for that. It won't trigger, but it runs continuously. For that, we need Snowpipe streaming. I didn't do any, the representation for Snowpipe streaming, but I forgot to do that, but that's how it works. And then we have external table. For external table also, we don't have any external stage or internal stage. We don't have any stage at all. What external table does is, we just define the external table outside Snowflake. In any cloud storage, we define the table outside itself and we don't import it into the Snowflake at all. We just query it directly from the external table, which is stored outside the Snowflake. That is what external table is. We use external table to store data, the storage space in Snowflake. Okay, that is how data loading methods work. Moving on to the demonstration. Now I'm going to demonstrate the basic method, the copy into method, We're already done with uploading the file, right? We're already done with uploading the file into the stage. We already have the file in the stage. And we also created a table. All we need to do is we need to write the copy into command to pick this data inside the file that is stored in the stage into the table. That's it. Let's do that. Into the table name. From @stg ecom. Going to attach this file format to this copy into command. Error. With this last line, we are saying if it faces any error with any of the record, just skip it and continue with the rest of them. Just to we need to make sure the whole process will crash for just one record. So that's why we say on error, just continue. That's it, I guess. And yes, let's run that. Okay, now it says the status has loaded, which confirms all the data is loaded successfully. Rows pairs, rows loaded, error limit, errors seen, 0 errors. That's a good thing. Yes, that confirms that data is loaded. Now let's check the table. E-commerce sales, data preview. There you go. We have all the data. We just have 30 records, by the way. We loaded all the data into the table that we created using the basic method copy into. And these are all strings. And next we just transfer data. We just process this data by parsing it into silver layer. Right now we just did the raw layer, but that is fine with the basic method. Now we're heading to streams. Okay, talking about streams now. We just heading. Streams are the way to track changes in a table. We create a stream. If we create a stream on one table, it captures every single change. I mean, there are types of capturing, but streams allows us for CDC, which stands for Change Data Capture. CDC. Which stands for Change Data Capture. So if we create a stream and we connect any of the table to the stream, that stream records every single change that is done to the table. It can be insert, update, or delete. Any of that will be captured into the stream. That's it. That's basically it about streams. And the types of streams include standard stream and insert only stream. Standard stream captures everything. It captures delete, update, or insert that is done to that particular table, whereas insert only stream or append only stream captures only the inserts and ignores the updates or deletes. It only captures inserts. These are the two types of streams. Let me name that too. So there is standard stream and insert only or append only stream. Standard stream, I just spelled it wrong, standard, whatever. Okay, there is standard stream and this is now how we write it. Standard stream. There is standard stream and there is insert only or append only stream. Standard stream, like I said, it captures everything: insert, update, or delete. Whereas insert only or append only stream only captures the insert events and ignores anything else like update or delete. That's it. That's it about the streams. Now moving on. The next one is tasks. Remember when I said we can automate copy into the data loading method. We can automate the copy into method by using scheduling it, by using tasks to schedule it, right? That is where task comes into picture. We can define a task. We can define a Snowflake query, a SQL query to be run at particular scheduled times. So they are SQL way of scheduling, Snowflake's way of scheduling SQL statements, and we call it tasks. We don't have any types of tasks, but yeah, we can schedule them. We can schedule to run that particular task. Let's say the task is to refresh a view or refresh a table or I don't know, any SQL statement, anything. So if you want to run that SQL statement frequently for at a scheduled time, for every 5 minutes or for every 1 hour, for every 2 hours, we use tasks to do that. That's it. There's nothing to draw anything for tasks. That's it. Now moving forward. Moving on. Now we are going to design a mini pipeline with the task, with the concepts that we are left with. Okay. We talked about stages. We talked about internal stage and external stage. I demonstrated about creating an internal stage, but I haven't demonstrated to create an external stage yet. So we're going to do that now. We're going to create an external stage. Then what else? We saw the basic copying method, which is copy into. So we saw the basic copy into method to copy the data inside the file to a table. But we haven't seen the second method, the Snowpipe, which is a very important method to capture the new files that is getting uploaded into the external stage. So we're going to demonstrate that. But we cannot demonstrate Snowpipe streaming because I don't have access to any API yet right now. So I'm going to demonstrate this Snowpipe and then what else? Then we talked about streams, right? Yeah, we're going to use stream as well in this mini data pipeline, and then we're going to use tasks in this pipeline too. Let's have a plan first about what we're going to do now. Okay, let me name this heading mini pipeline. I'm going to name this with the heading mini pipeline, and goes like this. Now I'm going to create an external stage. Define an external stage. We need a cloud storage to define an external stage, right? Right now I only have access to Google Cloud Storage. So I'm going to use Google Cloud Storage to as an external stage. The bucket in the Google Cloud Storage as an external stage. So this is an external stage. We're going to load our file, our CSV file into this external stage. Okay, and from there we use Snowpipe. Here to transfer any new files in this stage to a table, to a table here. And this is the raw table, by the way. This is raw table. So this is the raw table. Any new file gets uploaded to this external stage. This is external stage. The data in that file will be copied into this raw table using Snowpipe. Okay, and then we use stream here. Okay, we use stream here. Why am I doing this? Why can't I just type it? I'm going to use stream here to capture the changes in this table. I'm going to use stream to capture any changes in this table. And then I'm going to use task right here. By the way, we can only capture the changes using stream that we created, but we cannot actually capture the all the data in that particular raw table in this stream. So we need task for that. So the task, in that task, we're going to merge the changes that are captured by the stream into the target table. We're going to create another target table. Okay. In between, we're going to do some data transformation where raw table only has the data type as string, but the target table has the data parsed in the right way. So we're going to do that. Target, this is the target table. We're going to use stream to capture the changes in this raw table, and then we use task to schedule the merge for every 1 minute, because we don't have time to wait. So we're going to use 1 minute as the time interval here for the task. So for every 1 minute, this task, which is merge, will execute, and the changes will be captured and copied to the target table. Okay, now let's do this mini data pipeline. These are our plan, by the way. It looks horrible to the eyes, but it's a good plan. Let's do that. Like I said, I'm going to use Google Cloud Storage for the external stage because I only have access to that cloud platform. But if you want to use any other cloud platform like Azure or AWS, you can still follow along, because the process is same for any cloud platform. That just the tools change, the process is still same. And yeah, if you still doubt it, I can clear that up for you. So if you want to do the same with another cloud platform, you can just go to Google and click search for, let's say, Azure integration with Snowflake. You can get everything step-by-step guidelines for configuring Azure container for loading data into Snowflake right here in the Snowflake official website. You can do the same for, you see, they also have the coding. They also give you the code that you have to run. You just need to follow the steps and you'll get it. They have this for every single cloud platform out there. Let me do that for GCP, GCS, storage integration with Snowflake. You see, literally everything. You just need to follow the steps. You just need to follow the steps and do what it says. And at the end, you will connect that cloud storage to Snowflake. It is so easy. Okay, now I don't need to go through these steps now because I already done the process. Now I'm going to walk you guys through how we can connect a cloud storage to Snowflake. In this case, I'm going to use GCS. Before we begin, we have to drop these tables that we created earlier to demonstrate the basic copy into command. We don't need to delete the file format. We can just use the same file format for this. We need to drop the stage here. So I'm going to drop the stage. Stage is dropped. And I'm going to drop the table too. And then what? We have, that's it. We drop the stage, we drop the table. Yes, that's it. Let's refresh this. Okay, we just have file format stored in this database, in this schema. Now let's create a new notebook, a new worksheet, not notebook. I'm going to include all the queries from the beginning. So I'm going to give you guys this code file, the whole file that I'm going to use now for the mini data pipeline, so you can try it if you have GCS. But if you have any other tool, you can still get that code and replace that configurations with your cloud platform, then still do the same process. Okay, so I want to start writing the basic queries first. I know I already created that, but I just want to, because I'm going to give this file to you guys, so I'm going to write them again. With proper headings. Create initial frame. Database. Schema. You don't need to worry about even changing the database manually. You just need to run these queries line after line, and everything is done by the queries itself. That's why I'm writing this for you. We also need that file format that we created in the other worksheet, this one. Create file format. Okay, now here we are. The next step will be creating storage integration. Before that, we have to configure something in our Google Cloud Platform. To Google Cloud Storage, buckets. I'm going to create a new bucket here. Create a bucket. J sales. Say Europe 02. Because I created Snowflake in Europe, I just named the bucket as J sales Europe 02. You just need to make sure the bucket name is universally unique. So it should be lengthier. And you cannot use underscores, by the way. You have to use hyphens when you name it. Then when choosing the region, choose a region. Pick the region where your Snowflake account is at. Remember, when we create our Snowflake account, we have to pick a region from the drop-down. You have to remember that, or this bucket should be in the same region, or else you cannot access it. If you don't remember it, that's fine. You can just run this command. Select current location. I think that's the right. Okay, that is not. It is current region. That function works. Okay, so this will display which cloud platform you've chosen and the region you picked when you create the Snowflake account. And this should be the location of your bucket too. Mine is Europe West 4. So I'm going to go Europe West 4, which is Netherlands, right here. I picked it, single region, and I'm going to turn this off. Confirm. Here, I'm just creating a bucket in Google Cloud Storage now. Okay, now the bucket is successfully created. Now we created a bucket. Right now it's just a storage bucket that is in cloud storage. But we have to define this as an external stage in our Snowflake. To do that, we have to head back to Snowflake. Here. Now we need to create something called storage integration. We have to create something called storage integration to define that bucket as our external stage. We use create storage integration. We name it ECS int. type as external stage, because that is, we are defining it as an external stage. So the type is external stage here. Then storage provider. Our storage provider is GCS, Google Cloud Storage. GCS. Enabled equals true. Then storage cloud locations. Don't freak out. I'm just trying to demonstrate how we can connect to any other cloud platforms. How can we integrate that cloud platform as an external stage in Snowflake? And by seeing this, you might feel so overwhelmed, but this is not something you will remember. You just need to, like I said, you just need to go to any web browser. You can look up for that particular topic, and Snowflake has everything in their official website, and you need to follow all those steps. Even now, I'm not writing these queries by my own. I have everything written in here in my phone, so I'm just going through all those steps, and I'm just writing it in. But I'm just walking you guys through all the steps that we have to do. That's it. Don't freak out. It's just so easy. And and by the way, especially SQL is very easy. It's just a basic English. We just need to write what we have to do, what Snowflake has to do. That's it. Here, storage allowed locations. For this storage allowed location, we have to specify the storage location, the bucket location. To get that location, we have to head back to the bucket. Click on configuration to get the bucket configuration. And look for this side heading, GS util URL. You need that URL, copy that. Head back to Snowflake. Paste it here in storage allowed locations, but it should be GCS. In Snowflake, you don't take if you say GS. You have to say GCS here, or else you don't connect. So make sure of that. Then this is not mandatory. This is just to load a comment in. That's it. Now we define that external stage. We're defining, by the way, we haven't defined yet. We're defining that particular bucket as an external stage in our Snowflake using this query here. I'm going to run that. Integration GCS in successfully created. If you messed up anywhere in this step, this will fail. You have to make sure you use GCS, not GS alone. You have to use GCS here before the bucket name. So make sure of that. Now integration GCS in successfully created. Created the integration successfully. Now our next step, type in. We describe the integration first. Describe storage integration GCS underscore int. So we're describing the storage integration that we created. this should show all these properties, but the important one that we need now is this one, the service account. We already talked about RBAC, right? Role-based access control, where we control the access of that platform according to the roles that person have. And here in GCS, it is also the same. It is also our RBAC. So here we will get a service account for that storage GCP service account. We need to copy this service account. We need to give permissions to that service account in that GCS for that particular bucket, to read that particular bucket, to read that particular bucket. We have to allow the permissions for that. Yep. Okay, so we have to copy this service account that Snowflake provided us with. Go back to Google and head to IAM and admin. Like I said, the process is same with any other cloud platform. It can be Azure, it can be AWS, everything the same process. Grant access. Oh, I forgot to delete the old ones. I already gave access to this service account, so I'm going to delete that and do that again. Do that. Save changes. I deleted that and this one too. Now we're going to do that freshly now from scratch. Okay, now click on grant access. Paste the service account that you just copied. Now assign the role. For the storage integration, for that service account, we need storage object viewer. Object viewer. This one, storage object viewer. We just need to view the objects in the storage. Read that and then save it. Okay. I have that completed. And now we need to create notification integration. Now we have access to the storage, which is our external stage. We have access to it. We can read the data. We can read the data from the file right now. But what we're implementing here is we don't just want to read the data manually, but we want to automate it using Snowpipe, right? That's why we also need to create notification integration here. Notification integration, basically, we're going to configure that notification integration like whenever any new file added to that bucket, it pops a notification to PubSub. PubSub is basically like a streaming engine in GCP, just like Event Hubs in Azure. So it pops a notification saying a new file got added, and then Snowpipe, and that notification will be reached to Snowpipe, and Snowpipe will trigger the copy into command to copy the new file into the table. So our next step is to create notification integration. This GCS I don't just. Okay, now we just framed a query for to define the notification integration here, right? The type is queue, enable is true. We're just making sure the notification integration is enabled. Then notification provider is GCP PubSub. Like I said, PubSub stands for publisher and subscriber. So this is like a streaming platform in GCP. The notification provider is PubSub. The notification will be provided to Snowflake through PubSub. We haven't created PubSub topic yet, but we will now. And here, GCP PubSub subscription name. We're going to create subscription too. In PubSub, a publisher is the one who posts the data. A subscriber is the one who gets the data from the publisher. Now here, our GCP bucket sends the notification. So it is the notification is the publisher, and subscriber is us getting the notification when to actually run the copy into command. Head back to GCP, and here open PubSub. I'm going to delete this. Okay, I'm going to create a new topic. Snowflake notifications. And leave the rest as default. Create it. Just need the topic name, right? We need the subscription name, not the topic name. Okay. We have the subscription. Now let's create a topic. Now we have the topic. Now let's create the subscription. Make sure this should be pull subscription, not push subscription here. Subscription name be name it notify. Simple one. That's good. Yeah, that's it. Notify when I have to make sure it is pull. Now I'm going to create it. We just created a topic and a subscription in PubSub, but we haven't connected that to the cloud, the cloud storage bucket. We have to connect that to cloud storage bucket so it sends a notification to our Snowflake. Let's do that. We have to create, like I said, now we have to connect the notifications of the bucket to the PubSub topic. For that, we have to open the Cloud Shell. We don't have the UI for that in GCP. I don't know about any other cloud platforms, but for GCP, we don't have access to. We don't have UI to actually configure the notifications. We have to use CLI for this. Run the cloud storage buckets. Create. Now here we need our bucket address. Copy that. paste it here. Slash. I messed up. Yeah. Step. I have to write that again. I'm going to copy this again. Paste it. When we go to new line, we can't just hit enter here because we're in the CLI. We have to hold shift and then hit enter. Okay, stop that too again. Paste it here. Or yeah, paste it here. New line. Here I'm going to So what I found out is we're connecting a bucket notifications to PubSub topic here. Topic is a topic. Now we're creating notifications for that bucket, and the notification is just for the object finalized. And this event type is about when we upload a file and that file is finalized and it is actually stored inside the bucket, then the notification will pop up. That's how we define this event type here. There are a few more event types. Object finalize is used for that. Finalized object that is uploaded into the bucket. That's how we write that. I'm not sure about the next two lines, but yes. Hit enter. Close this. Okay. I need to format. Okay, now the notifications are created for the bucket. So that's good. Let's just close that. It back. The next step is to fill up the details here. For you have to fill up the subscription name here first. That we have to head back to PubSub. Notification. One that we created, notify. Now we have to copy this because that is our PubSub topic. No, the PubSub subscription that we created. This should be in quotes. That's it. Yep, everything's looking fine. Let's run that. Okay, now we created the notification integration. Again, we have to do this that we did before. We have to describe the integration. Just like we did for the storage integration. We do the same for the notification integration. Copy that. Run it. We'll get a different service account. And for this service account, we need to give two permissions for this. One is monitoring viewer and the other one is pub/sub subscriber. Let's copy this service account and assign the permissions to it in IAM. Okay, grant access. Paste our service account here and search for the role pub/sub subscriber. Perfect. And then we need a monitoring viewer. Monitoring viewer. We need this permission. Save it. There you go. Now we have all the permissions ready. We have the notification integration ready and the storage integration. Our next step will be creating creating the table, creating our raw table where the data lands directly. So that is a raw table, and then we create a target table, like I said. And between these raw table and target table, we create a stream and a task. The stream captures all the changes in the raw table, and then the task will merge the changes with the target table on repeated periods, synchronous periods. Okay, now we have that, and our next step is to create the table. Create table. Sales raw. Got the raw table created. It's created. Okay. Now we have everything ready to create the Snowpipe. We just need the raw table for the Snowpipe, right? We just need to get the newly uploaded file from the external stage to the raw table. So now we can create the Snowpipe. Let's create that. Create pipe. Sales pipe. Auto ingest. It's true. I think I forgot something. Yeah, I did forgot something. before creating the pipe, we have to create the, we have to define the stage. Okay, we have to define the stage first. We have to create the stage first. Okay, my bad. So after creating the notification integration, we have to define the stage here first. Forgot about that. Let's do that. We create the stage as ECS stage URL. URL will be our bucket URL. Storage configuration GCS. That is our storage integration that we just defined here, GCS int. And then we also define notification integration. Notification integration. File format that we already created, sales CSV file format. That's it. Now we have to run this. We have to create this stage first. I thought we already defined it, but we have to create it. Invalid property notification. I think I spelled it wrong. This is not part of the step, by the way. I'm so confused. You don't need this stage at all. You don't need to create the stage. That was the old Snowflake syntax. Now it is not valid, so we don't create the stage, by the way. This is the right process. Yeah, this is the right process. I just got confused. I just got a little confused. That's fine. Let's continue where we left it. We're creating the pipe, right? Integration will be our notification integration. Is GCS notification. As now we use copy into sales raw. From CS stage. I don't get it. I think I messed up. I think I messed something up. I think we do need to create this the stage. Let me just replace this. We do need to create the stage because we have to define the stage when we create the pipe. So we have to create the stage here. A GCS stage, a GCS, and should work. But the only thing I forgot is, I think, this one. When we define GCS stage, we cannot define the notification integration right here inside the stage itself. That was the old syntax. For the new syntax, you don't do that. I think this should work. This will create the stage. There you go. But you will define the integration, notification integration, when you create the pipe. So that triggers the notification triggers the pipe. So you define the you connect the notification integration to the sales, to the Snowpipe. And here for the from, here we use the stage that we created now. ECS stage, perfect. Now file format. Sorry, I just got a little confused with that. Equals, and the file format is sales underscore CSV underscore format. That's it. Let's run that. Hopefully it will execute. Okay, now the sales pipe is successfully created. Should we test it out? I think we should, right? Now, if we go to our bucket that we created in our cloud storage, and if we upload a file to this bucket, that file should be automatically, the data in that file should be automatically copied into that raw table that we created. So let's do the upload files. I'm going to upload the daily sales file again. That is uploaded. Daily CSV. Like I said, Snowpipe doesn't offer real-time streaming. It is near real-time, so we have to wait a few minutes. It can be 2 to 3 minutes to actually reflect into that raw table. This one. Then I'm going to create the headings for these queries. Create Snowpipe. Here we have our pipe created, file formats created, stage is created, raw table is created. Let's see if the file is actually in our stage. List. Great. CS. This should print out all the files that are uploaded to GCS stage. There you go. Now we got the file from the bucket, from the Google Cloud Storage bucket, and it is now inside Snowflake. We imported it successfully, which means we assign the permissions, we assign the access to that service account in the right way. So we already got the file into the stage, and we can see the file right here. But now the actual question is it actually inside the raw table? There is only one way to find out. I'm going to select the data from sales from not yet, not yet. Let's go to catalog, pipes. No copies found yet. So it is not triggered yet. It is running. It is still running, but haven't worked with any of the files yet. It haven't loaded any of the files. See a stage, and here we can see the pipeline, the pipeline from GCS stage that we created, and this is the sales pipe, and the destination is sales raw. Oh, I completely forgot. I just created the pipe, but I have to make the pipe run. After we create the pipe, it won't automatically start running. Is that what's happening? It's still running. You see. It will start running. I think it is running. I see. I saw that pipe, and yeah, it is running. Okay. Yes, finally, we did got a spike here in PubSub in pull. Then when I head to Snowflake and I head to sales pipe, and there I see it is just loaded, and there you go. There is our daily sales CSV. It is in our copy history, and it also shows how many rows, which means we can head back to our SQL worksheet. And when we try to retrieve the data from that raw table, it will print the records now. And the file has 30 records, and the table also has 30 records. So yes, our Snowpipe worked actually. Now let's create another target table and then create a stream to capture the data changes in the row, and then we create a task to refresh that, the merge between the stream and the target table. We're going to do that now. Let's create the table first. So that's the syntax. We use create stream and the stream name and on table to which this stream should be attached to. That table will be our raw sales table where the raw data will land. That we create the stream. Stream is created. We heading here. Create stream. Now we created the stream. So, which means if any action that happens to that raw table will be recorded with this stream. So let's test that out. Test that. Let's insert a new record into the table. Insert into sales raw. values as so we already have dates up to 2025 12/05. Let's do 2025 12/06. 12/06. Price as 3100. Run that. Number of rows inserted is 1. Okay, which means if we select from the stream, it does show. Like I said, you don't capture the old data, the past data the table has. It only captures the changes that the table going through. Here, the changes that the table went through is insert. So we inserted a new record and it says insert. And if it is an update, it says metadata update as true here. Okay, we have that. The next one, let's try with deleting a record from that. Let's delete the record that we just inserted. Sales raw. Where date text equals to the date that we just set. Okay, so we deleted the record that we just inserted, which means the stream should capture that one as well, the delete action. Actually, that won't, because that doesn't make sense if it captures both of them, because insert and delete, we inserted the same record and deleted the same record there, so it doesn't make sense, so it did not record it. But if we delete a new record besides the one that we inserted, let's say 5, now this will get recorded. Okay, now this will get recorded in the stream. So that's how it works. If we insert the same record and delete the same record, it won't get it won't get captured in the stream, because that doesn't make sense, right? That happens. I mean, nothing happened there. This is change data capture and not. It don't capture everything. It just captures the data that changes, the changes in the data, and not everything. And here we haven't changed anything. We just inserted the data and we deleted the same record, so it did not get captured by the stream. Okay, we did that. Now we know how this works, right? So that is how it works. That is how streams work. Our next step will be creating a task. Creating a target table first. Now, like I said, in our first table, because that is a raw table, we just define every data type for every single column as string. But here, this is the clean data table. So we define the data type, appropriate data type for them. That's why sale date will be date data type, and sale amount will be number data type. We create this table. We created that. I have the target table ready. Now we need to create the task. To merge the stream, the changes that are captured by the stream with the target table. We are merging them. So I'm going to name it sales merge task. I have to define the warehouse. Schedule it. Like I said, we can schedule it with any time frame. Now here I'm using 1 minute as our time interval. One minute. You can do, if you want to do that for 1 hour, for every 1 hour, if you want to schedule it for every 1 hour, you can just literally write hour here instead of minute. Say hour, and it is scheduled for hour. But we don't have that much of time, so we say every minute. Sales lead as target. We're aliasing the table here, by the way, as TGT using select. We're casting columns now. Date.txt is the column from the raw table. Date, we're casting that column as date because that was string in the raw table. Remember here, both of them are strings, so we have to cast this date text as date data type and sales text as number data type. Might get confused with these SQL queries. Like I said, it is always better to learn SQL first and then learn Snowflake. You can just directly run Snowflake, but I'm trying to explain every single query that I write, so you will not get, you can catch up with the flow. So I'm trying to explain every single query, every single line that I write here. Stream. SRC, because that's the source. Say SRC for that. TGT. Here we created a task that is scheduled for every minute to run every minute, and the task is this, is to merge the stream with the target table. Here we selected 2 columns and we casted those columns from the raw table with their appropriate data types, and then we used metadata actions where if the data is deleted, delete that particular record from the target table too. So these 2 tables should be in, these 2 table has the data, these 2 tables should be in coordination. If the record in the raw table gets deleted, that same record in the target table should also be deleted. That's why, and if any new record got inserted into the raw table, that record should also get inserted into the target table. That's what we have done here. If the source table action is delete that row in the target table too. And if it is updated in the target table too. If it is insert it into the target table. That's what we're doing here. Now let's run that. Let's run the task. Okay, now the task is successfully created. Okay, which means now whatever the action that is done on that raw table will be reflected to the target table. But like I said, stream cannot access the past data. It can only past actions. It can only capture the present, the actions that are done after connecting the table to the stream. What I mean is, here our sales raw table has 30 records, I think 29, because we deleted one. We deleted one, so it has 29 records. But we inserted these records into the raw table before we create the stream. So this data is not captured into this insert data is not captured into the stream, which means the target table will be still empty. I think you get it, right? We cannot access the past transactions. It only accesses the transactions that are done after connecting that stream to that table. Let me show an example first. Now, by the way, after we create task, if we go to catalog, refresh this, you can see the task right here, but it is initially suspended. You have to start it when you create it, or else it will not run. So you have to start it. You can also see that tasks right here under the transformations, all the tasks that we create. You can see it here, right here. Right now it is suspended. We have to run it. We have to start it. We have to resume it. But to resume it, we do alter task and the task name, which is sales merge task, and say resume, just like that. Run that. Now when you go to transformations, tasks, have to refresh it. Now it is active. Now it is started. From now, whatever the action that happens to that raw table will be captured into the target table. Let's demonstrate it. Okay. Right now, like I said, our sales clean table will be empty. Okay. Because there is no changes done for the raw table, which is the source of this table. There is no changes done yet. Select all from table. Right now it is empty. But what if we go to cloud storage, buckets, the bucket that we created that is connected to the stage. If we upload a new file, okay, I'm going to upload the same file but with a different name. So this will trigger the notification, which means this will be copied into the raw again, which captured by the stream as a change data capture as an insert. So it is captured, and then this inserted data will be reflected into the target table by the task by merging it, by merging the stream to the target table. And this whole process, like I said, it takes a few minutes to execute. Now let's go check our stage that we created. Let's see if we can, yeah. The file is already inside the Snowflake stage. Right here, daily sales copy.csv, but I'm sure it's not reached to Snowpipe yet because the Snowpipe will only get triggered if there is a notification sent to this topic. And right now there is no spikes yet here, right? So if there is a spike, if you see a spike here, that means the notification is sent to the Snowpipe, which executes the copy into that new file into the table, and then that gets inserted. Now we got the spike here. This is a spike we need. These are green flag that our data actually triggered the Snowpipe. So when we go to catalog and open the Snowpipe, there you go. It is loaded 3 minutes ago, by the way. So our new file is also got loaded, and the file name is daily sales -copy.csv, which means we go back to this is the worksheet. Okay, now let's query our raw table first. So this should have 59 records. There you go, 30 plus 29, 59 records, and these inserts will be captured by the stream. Now let's select everything from sales stream first. Oh, it is already captured. Okay, now we go to the clean table, the sales clean table. Here, all the changes, all the inserts, the new inserts got captured by the stream and merged with the new table. So we have 30 here. You got it, right? So yes, that's how it works. This is a very small data pipeline that we just created here. That runs automatically whenever a new file gets added to that cloud storage. We don't need any human intervention. This is just a one-time process that we do, and everything runs automatically. But, yeah, that's it. Okay, now we know about this, which means, so I hope you got the data pipeline and how it works, right? Everything is automated here. The only thing that we need to deal with is we just need to upload the file into cloud storage. I mean, in real world, we don't upload it manually, but we just these files will be created automatically in the real world, in the enterprise grade projects. These projects will be automatically created and stored in the cloud storage, and then that will be captured with Snowflake, and there we do the cloud data warehouse. But here we don't have we haven't created that big of a project. This is just a course, a masterclass. So I just created a small data pipeline just to show you guys how this Snowpipe works. With that, we done demonstration for Snowpipe, external stage, and a stream, and a task. Moving on to the next one, which will be data loading methods. No, this is not data loading methods. This should be data cloning, zero copy cloning. So there is another topic named zero copy cloning. Thing you have to know about this is, like the name says, when you clone a table, when you clone a table, when you clone a table, when you create another table, when you just duplicate one table to another table, in Snowflake, you don't create another storage. Let's say this is the table that you copied, and this is the storage that the table used, the data storage. If you clone that table into a new table, you don't create another storage. You don't duplicate the storage. It only duplicates the table, but still, this clone table will also point to the same data storage. So when you clone the table, the storage usage will not get doubled, because it still points to the same storage, but with a different table. And Snowflake has this feature. So if you want to copy a table, you don't increase the storage consumption. Just for the cost reduction, you have this feature. And moving on to the next one is time travel. I think we haven't talked about time travel yet. So that is our next topic. That is one of the topic. And our next topic is time travel. Like I said, I told you already, we're going to deep dive into this topic later. Now is the time. Time travel allows us to go back in time and go back in time. That's it. Let's demonstrate an example to make it clear. All right. Here we already have a table, right, that we created here. Table already, which is sales clean. So I'm going to select that, but the dates. Okay. To show a small demonstration of how time travel works. Okay, so now we have how many records? We have 30 records in this cleaned target table. If we delete a record from this, delete from sales clean, sale date is 25/12/05. 25. 5. What this does is it deletes this record from the table. It is deleted, right? When we select it, it is not there because it is deleted. But what if I say you can go back in time to whatever query that changed your table, which can make your table to time travel to its old state. Whatever you've done, whatever the queries that you've done after that query will be erased, and it goes back to the past stage. That is what time travel means. So here I just deleted a record from it, right? Which means it only has 29 records right now. Now if I write create table, sales clean restore, here I'm going to say the query ID. To understand it so well, I'm going to do another operation too for this. Same thing, okay? I deleted sales screen where the sale data is 2025 1205, right? I'm going to insert another record. Okay, I'm going to do now. I'm going to insert a new record into the same table. Insert into sales clean. And the values are 2025, 2012 06, and 310, 3100. I'm going to insert this one. It is inserted. Now, if I select every record from that table, we will have 30 records. But instead of 05 as state, we have 06 here, which means we did two operations. What if I say we can go back in time and get the table that we had before executing these two queries? That is what time travel offers you. You just need the query that you executed before those two operations, the query ID. For that, we have to hit the monitoring, which has the query history, right? And here, the query that is first done is delete. We deleted that and then we inserted that. So we need to go back in time. We need to go back in time. We don't want the insert and we don't want the delete too, which means we need this query, copy this query ID, go back to the notebook, the worksheet. Here, paste the query ID. What this does is, it creates a clone table of that sales clean table. You don't change the the default table, but it creates a clone table and that clone table represents the sales clean table before executing these two queries. It goes back in time. That's what time travel means. So it says before statement, and the statement has query ID. Before this query ID, it goes back in time. If I run that, now it creates a new table, right? Now let me create another select query right underneath this. Okay, what was the actual table? It has 30 records, but instead of 05 as stated, it has 06. But now this time travel table, which doesn't include these two operations, insert and delete, this will also have 30 records, but instead of 06, it has 05. So it went back in time. That is what time travel means. In Snowflake, this is an exclusive feature in Snowflake. Not exclusive, it also has you can also see this feature in a few other platforms, but Well, Snowflake also has it, and it is so easy to time travel. It doesn't even need much coding knowledge for that. These are way, and there is another way where you can, instead of going back in time with query ID, you can go back in time with time. Yeah, with time, with actual time. You can say 60 seconds back. So you can get the table that was 60 seconds back without any operations done on it. I think I explained it right. I hope you get it. This topic is Snowpark. Snowpark lets you create data transformations, lets you do data transformations or do ML operations just by writing Python code inside Snowflake itself. You don't have to, export this data into an external environment to write this Python code. You can write Python code right here itself. Like I already show you before at the beginning, you can create a Python worksheet to write Python codes directly in Snowflake. That's how it works. There is another thing we have to talk about is Streamlit. Streamlit lets you create applications or create advanced dashboards in Snowflake itself. That is one of the new features, that and the Snowpark are the new features in Snowflake that you have to know. Yes, but in Snowflake we mostly use SQL, but if you want to use Python for ML or data transformation, you can use Snowpark. That's just optional. And just the same way, we have a Streamlit for dashboards, advanced dashboards. If you want to use that in Snowflake itself, if you don't want to go out of Snowflake, you can do that too in Snowflake itself. But if you want to create a basic dashboard, I'll show you how to create that right now. Click on this and click on dashboard and say, name it something. I'm gonna name it sales from SQL worksheet. Here, I have to choose our database and the schema. Now I'm going to create a time series line chart which shows the sales over time. Do that. Select sale date, sale, set amount. I think it's amount. Let's see. Sale date and sale amount. That's correct. From sales clean. You just need to select those columns that you want to create this line chart with. And then you run it. Run it. Just like that. Switch to chat. There you go. Sales over time. The x-axis represents the date and the y-axis represents the sales. If you close it, it is added to the dashboard. In the same way, you can even create a KPI card that we create in RBI or Tableau. You can do that here too. That and select. This is sum of sale amount from sale clean. So this sums all the amounts into a total and creates a KPI card. Switch to chat, and here pick whatever chart you want. Like I said, this is not advanced, this is just a basic dashboard creation tool where you can create basic charts like line chart. We have line, bar, scatter, heat grid, and we have scorecard. Scorecard is just like a KPI card like this. It's not too advanced, but if you want to create advanced dashboards, we can do that using Streamlit. That's a new feature in Snowflake. There you go, like that. We create multiple charts to create this dashboard. That's how we do it. But if you want to We want to see a full-fledged project where we import the data into Snowflake and do the data transformation and get the dashboard at the end. Everything using Snowflake. I did do a project and I will leave the link down below in the description. Don't forget to check that out. And also check the channel. I uploaded a lot of projects using Snowflakes. So check every project that you possibly can. So you will understand a lot more about Snowflake just by watching those projects. Yes, with that, this is the end of this masterclass. Hope you gained some knowledge, some sort of knowledge, anything that is. I don't expect you guys to learn everything about Snowflake in just one video, but hope you gained some sort of knowledge from this video. If you did, don't forget to like, subscribe to the channel. With that being said, take care, adios.